Hello fellow coders, what's up? In this video, we're gonna go over a rather straightforward interview question. We are going to decide whether a string is a palindrome or not. And what exactly a palindrome is, I'll be covering in a second. This is kind of a cool introductory interview question because there's many ways to solve this problem. And each of these methods teaches us different algorithmic approaches. And it also forces us to think about optimizations we can do along the way. In this video, I'll be going over what exactly a palindrome is, but I will also show you 3 different solutions of how you can tackle this problem. I'll also be doing a short runtime and space complexity analysis. So let's just jump straight into it. So what exactly is a palindrome? If we look at what Wikipedia has to say about this, a palindrome is a word, number, phrase, or other sequence of characters which reads the same backward as forward, such as madam or race car. So let's look at a few examples right here. First, we have the simple string ABA, and this is definitely the same backward as forward. The same is true for race car. But then if we look, for example, at hello world, DL row ole or something like that is definitely not the same thing as hello world. So this last example here would not count as a palindrome. How do we now solve that problem? Let's take our example from the Wikipedia page, which was the race car. One way how you could approach this problem is by setting up some kind of a buffer variable. Let's just call it new string, and it's an empty string. And then you go over each character in the input string, but starting at the end and iterating up until the first character. And at each turn of this so-called loop, you just append the current character to the new string. And what this means in programming terms is that you start a loop at the end of the input string, and you iterate over each character until you are at the first character. So if you look at this in action, it means that at the first turn of the loop, we are beginning at the last character, which is the R. And then we just append that R to our new string. In the second step, we move the cursor to the second last character, which is the A. And we just append this character, the A, to the result of the previous round. So then we have the string AR. We continue doing this until we are at the first character, which is the R, and then we take the results of the previous rounds and just append the last, or in this case, the first character of the input string to the result of the previous rounds. So we then have race car. And then we are pretty much done, because the only thing that is left, we just have to compare the new string with the initial string. And then we can say, okay, the input string is a palindrome or not. And in this case, race car equals race car. All right, quite a lot of talking for such a simple problem, right? But the reason why I'm doing this is to also demonstrate what you should be doing in your interview. You should not just jump straight into your IDE and then throw out some cool code with some fancy syntax. The first thing you should be doing is take a sheet of paper or go to the whiteboard and then walk the interviewer through your thought process. Clearly communicate what you want to do. And this is your chance to demonstrate to the interviewer that you're a kind of person that can communicate and that you can present your thoughts. And this is super important in the software industry. With that being said, let's just for once jump into our IDE and solve the problem. I'm going to start by declaring a function is palindrome, and it's going to receive one input, which is the input string. And just to verify that everything's working, let me just put this here, A. We are going to call that on the terminal. We see that our setup works. All right. As mentioned in the presentation, the first thing that we want to do is we are going to create some kind of buffer variable. Let's call it new string and initialize it as an empty string. Then we are going over each character in the input string, but starting at the last character. We are going to do this until we are at the first character. And at each turn of the iteration, we are going to decrease the counter of the index by 1. Then once inside the loop, at each turn of the iteration, we are going to append the current character to our new string. And once we are done with that, we are just going to compare the new string with the input string. And voila, this should give us the solution for whether something is a palindrome or not. Let's just verify what we just have done. Seems like ABA is a palindrome, which is, for me, true. Let's just verify that things are working out with something else as well. All right, everything seems fine. AB blah 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 is definitely not a palindrome. Let's talk about the space and time complexity. I want to start with the space complexity because it is a bit more straightforward in this example. As we only are storing the new string here and nothing else is required in the memory, the space complexity results in a big O of n, because a new string is always as long as the input string. The time complexity, on the other hand, is sometimes a bit confusing for beginner programmers. One thing we can say for sure is that the time complexity is at least a big O of n, because we are going over each character in the input string. But the thing inside the for loop is basically another for loop. And the reason for that is that string concatenation in Python or other languages, like in this case, JavaScript, under the hood, for string concatenation, it always returns a new string and then goes over each character in the old string and appends that individually to the new string. And this is why we have two for loops in here. So this then results in a time complexity of big O of n squared. This is already a good solution right here. I mean, the space complexity is fine, the result we are getting is correct, but what seems kind of off for me is the high time complexity. So this is a thing we want to improve. And there's one way how we can easily do that. As just mentioned, the expensive thing to do here is this string concatenation. And we can get around this by just using an array instead of the string here. And then instead of doing a string concatenation at each step, we will be just pushing in the elements into the array. And this is way more efficient. I mean, pushing to an array is nowhere as complex as doing this mechanism of the string concatenation. And this results in the overall complexity, or the time complexity, being just a big O of n. And this is way better than the previous solution. Let's just confirm that everything we did was right. Oh, it's returning false, so something is still missing. Ah, I just see it. I mean, we cannot compare just a string with an array, so the thing we have to do here is not pushing in. we just have to join the individual elements, and then we have a string again. All right, everything is working again. What if your interviewer now asks you, can you do better than that? And now you're a bit confused and think, wow, it's already pretty good, what can I do? And then he gives you a hint and says, maybe you can do that whole operation in place. I mean, you could reduce the space complexity here. And then you start thinking. And one last solution I suggest you to do is a so-called two-pointer approach. So we will just declare 2 pointers here. One is the start of the string, and the second is the end of the string. So string.length -1. And then what you will be doing is again some kind of loop, but you will go through over each element, meaning first you compare the first element with the last element, and then you compare the second element with the second last element. And obviously you have to work around with these pointers right here, but that's a thing we can deal with. So the whole setup looks like this. As long as the left pointer is smaller as the right pointer, the thing we will be doing is we want to compare both characters at the respective pointers. So we have the left index, and we need to compare that with the right index. And basically what we need to verify is that are these two indexes or the characters at these respective indexes the same? So let's just try to verify that. And if they are not the same, so instead of comparing them like that, we do this. Let's just return false. Else we just increase the counters or decrease this counter right here. And if this whole loop passes without throwing false at any point, we know we have a palindrome. So not false, but return true right here. Let's just see what we have done. All right, it's returning true. Let's check once again with something else, and it's returning false. So this solution has the same time complexity. I mean, we have to go over all the elements once again, but we can do everything in place. We don't have to store the whole array, the whole string in an array or in a buffer string like we did in the first solution. This results in the same time complexity, but the space complexity improves to big O of 1. Actually, I have one bonus solution for you, which I did not mention in the beginning, in order to fully explore the problem and see what kind of solutions we can come up with. And this is a very short solution, which would be perfectly fine as well. So JavaScript offers a method which is called .split, and this will split the individual characters into a new array, and then we can call the array method .reverse, and when we are done with that, we can then join the string or the elements of the array back together and compare that with the input string. And this is basically the same as we did with all the other solutions. ABA is a palindrome. And this brings me to the end of this video. I hope you learned a ton. If you have any questions, just leave a comment. And if you liked the video, feel free to subscribe. Until then, see you next time.